So most beginners think programming is about learning a language. JavaScript, Python, Java, Go, Rust, C Sharp, Swift, Kotlin. But the real secret is this: programming languages are just tools. The deeper skill is learning how to think like an engineer. Once you understand the patterns underneath every language, you can become language agnostic. That means you are not trapped by one syntax, one framework, or one ecosystem. You can move between technologies because you understand what they all are trying to do. Now, in this video, I want to break down how to become language agnostic. This is one of the most important skills for a serious software engineer because the industry changes constantly. Today it's JavaScript, tomorrow it's TypeScript, then Go, Rust, then Python for AI, then Swift for iOS, then Kotlin for Android, then something else. If you build your identity around one language, you become fragile. But if you understand the core concepts, you become flexible. That is how you survive in tech. Now, every programming language is trying to help you do a few basic things: store data, transform data, control logic, handle errors, organize code, communicate with systems, manage memory and resources, build abstractions, create reusable behavior. That is it. The syntax changes, but the problems are the same. A variable in Python is not that different from a variable in JavaScript. A function in Go is not that different from a function in TypeScript. A class in Java is not that different from a class in C Sharp. An API call is an API call. A loop is a loop. A conditional is a conditional. A database query is a database query. The language changes the shape, but not the underlying problem. Once you understand that, learning new languages becomes less intimidating. Now, syntax is the surface level. A lot of beginners get stuck on syntax. They ask, where do the brackets go? Do I need semicolons? Is it const, let, var, def, func, fn, public, static, void? Do I use parentheses here? Why does this language use indentation? That stuff matters, but it is surface level. Syntax is the grammar, but programming skill is the thinking underneath the grammar. Imagine learning spoken languages. English, Spanish, French, and Japanese have different grammar, but they all help humans communicate ideas. Programming languages are similar. They have different syntax, but they help humans communicate instructions to machines. So yes, learn syntax, but do not confuse syntax memorization with engineering ability. Now, before I continue here, I want to just quickly note this website is called Learn X in Y Minutes, and it's a very good resource for anyone learning to become language agnostic. It has pretty much every language you can think of here, and it has these languages in various, I believe these are various formats. Let me move this out the way. So yeah, it has these in various languages. So I think that was in German. So you can come here and you can learn about pretty much any language you want. I'll go ahead and click on COBOL since that's more interesting and a more older language. So COBOL is a business-oriented language revised multiple times since its original design in 1960. So it'll give you everything. It'll give you, a lot of things about COBOL, some sample code. And what I used to do is I used to come in here and to learn xnyminutes.com, and I would go to the JavaScript section, and I would type out this entire thing. For example, just really quickly here, I will go here, and so I would type this entire thing out over and over and over again, repeatedly. I would type it out because I was trying to memorize everything that's in here, because this is essentially teaching you how the language works using the language. So I would just come in here and type this out. So I would be typing this out, essentially learning how JavaScript works on a subconscious level. So it might seem counterintuitive for someone who might not understand what I was trying to do, but this is all trying to get this information implanted into my brain in a subconscious way. So back to the video here, or back to our main topic, which is becoming language agnostic. The concepts that matter everywhere if you want to become language agnostic, right? You want to focus on these concepts that transfer from each language. So number one is data structures. Number two is going to be arrays. Number three, list. Number four, maps. Number five, objects. Number six, sets. Number seven, stacks. Number eight, queues. Number nine, trees. And number 10, graphs. So these are going to show up everywhere you go, no matter what language you're using. Now, number two, well, actually, number one is data structures. Okay. And everything I listed: arrays, lists, maps, objects, sets, stacks, queues, trees, and graphs. These are all data structures. I didn't mean to make that sound confusing. Now, The number two concept is going to be control flow. So these are all things that help you control the flow of the app. So if statements, loops, switches, pattern matching, recursion, async flows, which async means asynchronous. So you want to learn what all these concepts mean and study and master them as opposed to trying to master one language. Then we have number three, functions. And then we have, so as it pertains to functions, we have parameters, return values, pure functions, side effects, callbacks, high order functions, and closures. So parameters are what functions take in. Okay, so you wanna learn and master functions. Number four, you have types. So you have static typing, dynamic typing, type inference, generics, interfaces, enums, union types, and null safety. Number five, you have error handling. You have the try catch, result types, exceptions, optionals, validation, retries, fallbacks. Number six, you have modules and architecture. You have imports, packages, services, controllers, repositories, components, layers, and boundaries. Number seven, you have concurrency. You have threads, promises, async await, event loops, go routines, actors, and message queues. Number eight, you have memory and performance, garbage collection, manual memory management, references, pointers, copies, stack versus heap. Now, once you understand these, a new language becomes a new dialect, not a whole new universe. Now, let's say you want to build a simple API. In Node and TypeScript, you might use Express or Nest.js. In Python, you might use Fast API or Django. In Java, you might use Spring Boot. In Go, you might use Net, HTTP, Gen, or Fiber. Different tools, same core ideas. You still need roots. You still need request validation. You still need authentication. You still need database access. You still need error handling. You still need logging. You still need test. You still need deployment. That is the whole point. A senior engineer does not panic because the framework changed. They ask, where are the roots? Where is the data model? Where is the business logic? Where is the database layer? Where is the auth middleware? What are the environment variables? Where are the tests? And how does this deploy? That mindset is language agnostic. Now, companies do not really want someone who only knows syntax. They want someone who can solve problems. If the back end is Java, can you understand it? If the front end is TypeScript, can you build in it? If the AI prototype is Python, can you contribute? If the mobile app is Swift or Kotlin, can you reason about it? If the infrastructure is YAML, Docker, Terraform, and Bash, can you survive? Modern engineers touch multiple layers. The best developers are not language fanboys. They are problem solvers. They pick the right tool for the job. Python might be better for AI scripting. TypeScript might be better for full stack web apps. Go might be better for simple high performance services. Rust might be better for systems programming. Java might be better for large enterprise systems. Swift might be better for native iOS. Kotlin might be better for Android. SQL is still king for data. The point is not to worship one. The point is to understand trade-offs. Now, how to learn a new language fast. So this is my process. First, learn the basic syntax. Variables, functions, conditionals, loops, collections, imports. Second, learn the type system. Is it static or dynamic? Does it have generics? How does it handle null? How does it model objects? How does it handle interfaces? Third, build a small CLI app. CLI apps force you to learn input, output files, errors, and structure. Fourth, build a small API. APIs teach routes, JSON, validation, database access, and deployment. Fifth, read the real code. Do not only watch tutorials. Read GitHub repos, look at how experienced developers structure projects. Sixth, rebuild something you already know. Now, this is powerful. Build the same to-do app in Python, TypeScript, Go, and Java. Not because to-do apps are exciting, but because repeated projects help you compare languages. You start seeing patterns. Now, AI coding tools make language-agnostic thinking even more important. Why? Because AI can help with syntax. If you forget how to write a loop in Go, AI can help. If you need a Python script, AI can draft it. If you need a TypeScript type, AI can suggest it, but AI cannot replace your judgment. You still need to know whether the code is correct, whether it is secure, whether it is maintainable, whether it fits the architecture, whether it handles edge cases, whether it should exist at all. So in the AI era, memorizing syntax matters less, understanding systems matters more. This is the shift. The better you understand programming fundamentals, the better you can command AI tools. Here's my take. Do not call yourself a React developer forever. Do not call yourself a Python developer forever. Do not call yourself a JavaScript developer forever. Those are tools. You are a software engineer. Think bigger. Languages are temporary. Concepts last longer. Problem solving lasts the longest. The real skill is not knowing every language. The real skill is being able to enter a new code base, understand what is happening, identify the patterns, and become productive quickly. That is what language agnostic really means. In closing, the real secret of every programming language is that they are all different ways to solve the same core problems. If you want to level up, stop only asking what language should I learn. Start asking what concepts do I need to understand. Learn data structures, learn APIs, learn databases, learn types, learn architecture, learn testing, learn debugging, learn deployment, learn security, learn performance. Then the language becomes a tool, not a prison. Like the video, subscribe, and comment below. What programming language are you learning right now? And more importantly, what are you trying to build with it? I'll see you in the next one.